So the last thing we are going to look at today is area between two curves. If you thought it was cool that you could figure out the area underneath a curve, or if you at least listen to me think it was cool, because I think it's pretty cool. It's even cooler now that you can figure out the area in between two curves. So what does that mean? Well, all we're going to do, and we'll use our first example and just sort of a rough picture of what's going on. Can you see y equals x squared plus 2x plus 2? That's going to be some parabola that's opening up. And this is a perfect graph of it because I haven't given any scale or any axes, so we can assume it's perfect. Okay? And then y equals negative x squared plus 2x plus 10 is going to be some sort of parabola going down. And what we're going to try and find is this area here there we go. Oh man. This is not giving me the instant gratification that I want. Okay. We're going to try and find that area underneath that curve. Well, how are we going to do that? We're going to say, imagine I did have axes here, and these are not drawn in the right spot. But just for thinking about this, let's pretend that that's where that is. If I find the area under the green one, from here to here, let's say I color the area under the green one in green. So under the green one, oh my goodness, this is not fun anymore. It's so slow. Maybe if I have to lift, so if there we go. Perfect. That would be the area under the green one. What about the blue one? Well, I'll color the area under the blue one in blue. Nice. And if we took the green area and subtracted the blue area, what would we be left with? Just that area in between. And that's what this is talking about. If you want to find the area in between two curves, find out where they intersect. And then if you do the area of the one above minus the area of the one below, you'll get the area in between the curves. And the nice thing about this is it doesn't matter where these axes are. Even if they were like here, can you see that, oh, some of it's below the x-axis, some of it's above. How am I going to deal? Do I have to find all the x-intercepts and everything? No. It works out perfectly no matter where your axes are. If you figure out the big one, which is the one on the top, and which is the one underneath, and subtract them, you will always get the area in between those two curves. So in this case, can you definitely see that if these two intersect, that the green one would be the curve on the top because it's opening down, and the blue one would be the curve on the bottom opening up. But we would have to do first is find out, do they in fact intersect, and what are these two values? How do we do that? Well, we need to find out where equations intersect. That happens when the equations, the first one, is equal, whoa, I keep wanting to do equal, is equal to the second one. And how do I solve this equation? Move everything over to one side. This is going to be 2x squared Two x's cancel out. Minus 8 equals 0. 2x squared equals 8. X squared equals 4. So x equals plus or minus 2. Perfect. We had drawn our axes in the right place to begin with, it seems. Okay, maybe not. But if we move our axes like that, it works out. So now we find out that it intersects at -2 and at 2. So to find the area in between those two curves, we can set up our integral from -2 to 2. Which function is on the top? That would be -x squared plus 2x plus 10. Which function's underneath is the blue one, which is x squared plus 2x plus 2. Now you have a choice. You have a choice to separate them, not a good idea, and do each integral separately, or to just keep it together like the first one, because if you keep it together, what are there? There's some like terms. Instead of having to integrate a whole bunch of things, if we combine our like terms, we get -2x squared. 2x's cancel out. 8 plus 8 dx. And that's going to be a lot nicer. So now when we integrate, we're going to get -2x cubed over 3 plus 8x. Plug in 2. -16 over 3 plus 32. Plug in -2. 16 over 3 minus 32. We're going to get 32 over 3. Oops, yep, -32 over 3 plus, thank you. I think I added the 16s in my head before, because it's going to be 32 down there, plus 32. So if you got a common denominator of 3, you've got 96 over 3 minus 32 over 3. Which will give you 64 over 3 units squared. I'll put things up, see if you've got things set up. And then once you evaluate it, there's your final answer.